Let's face it, wading through medical information can feel like trying to understand a whole new language.
Mm,
All those specialized terms can be a real turnoff.
absolutely. It often seems like, you need a medical degree just to grasp the basics of how your own body works.
Exactly.
Yeah.
So, for this deep dive, we're taking a different approach. Think of this as your straightforward guide, your arts anatomy cheat sheet, if you like.
Mm.
Our goal today is to explore how your amazing body and brain connect with the world through your senses. And we're going to explain it all in plain language without getting bogged down in, well, complicated jargon.
Yeah, we'll be looking at the fundamental science behind these interactions, revealing just how deeply you're connected to arts and aesthetic experiences,
Right.
and how those experiences impact your overall well-being and how you learn.
We've got some really fascinating insights here that, get to the heart of how this all functions. By the time we're done, you should have a much clearer understanding of why and how the arts and aesthetics have such a powerful effect on you, both physically and mentally. Ready to jump in?
Definitely. Let's get started.
All right, let's consider your sensory world. You're constantly taking in information through your five senses: smell, taste, hearing, sight, and touch.
Way basics.
And
Yeah.
it turns out these are the fundamental ways you're wired for the arts, as our sources put it. Let's begin with smell. Interestingly, smell is one of the earliest senses we developed, evolutionarily speaking.
That's right. It's a very primal sense, and it's quite remarkable how capable your nose is. It's estimated you can detect around 1 trillion different smells.
A trillion. That's incredible. And get this, you have over 400 different kinds of scent detectors in your nose, and they even renew themselves regularly.
Mm-hmm. Constantly refreshing.
Plus, here's something I found surprising. Humans can actually identify some smells better than dogs. Who knew?
Yeah, that one's counterintuitive, isn't it?
It really is. Now, this direct link from scent to our brain's emotional centers,
Mm-hmm.
it highlights why a simple smell can instantly bring back powerful memories and feelings.
Indeed. And the process itself is quite elegant, really. When something has a scent, it releases tiny molecules that travel into your nose.
Okay.
These molecules dissolve in a bit of fluid on a special lining inside your nasal cavity, the olfactory epithelium. Think of this lining as being just covered in tiny detectors.
Okay, so tiny molecules meet the detectors. What happens next?
Well, these detectors are actually nerve cells, neurons, the basic messengers of your brain and nervous system.
Gotcha.
These nerve cells send signals up to a part of your brain called the olfactory bulb, which helps you identify different aspects of the smell.
Okay, signal scent. Now, this is where it gets really interesting, I think. The information we have emphasizes a crucial connection between the smell processing part of your brain, the olfactory cortex, and the temporal lobe, which is heavily involved in your emotions and memories. This close link explains why smells can trigger such immediate and strong physical and mental responses.
Precisely. I mean, consider how a particular smell can instantly transport you back to a specific moment or evoke a strong feeling, often without conscious thought.
Totally.
For example, the smell of a newborn baby releases oxytocin, often called the love drug, promoting bonding.
Yeah.
Or a familiar perfume can instantly trigger memories of someone. And get this, chemicals released when you cut grass can actually help reduce stress by lowering cortisol levels.
Away.
Yeah, thanks to the connection between your sense of smell and the emotion and memory centers in your brain, like the amygdala and hippocampus.
So our senses aren't just passive receivers, they're actively interpreting and shaping our reality.
Exactly, they're constantly talking to our emotional brain.
Okay, moving on to taste, we encounter another sense that works through chemistry. Your tongue is covered in over 10,000 taste buds,
Loads of them.
which, when they encounter food, create electrical signals. These signals then travel to the taste processing area of your brain, the gustatory cortex, which, interestingly, is also involved in those deep gut feelings and your emotions.
Right, that connection is key. It makes taste incredibly effective at encoding memories.
So that explains a lot.
Yeah, think about how certain spice combinations like nutmeg, clove, cinnamon can instantly evoke feelings of holidays for many people.
Oh, definitely. Thanksgiving smells.
Exactly. Or how, in some cultures, specific tastes, like marigold flowers, are linked to celebrations or rituals. And it's not just cultural, it's also those personal comfort foods that bring feelings of safety and love.
Mom's cooking.
Precisely. Taste becomes deeply intertwined with those emotional and sensory memories.
Now, let's turn our attention to hearing. This is a bit more complex, involving not just your ears, but significant processing in your brain. It's not just about sound waves hitting your eardrum, is it?
Not at all. There's a whole intricate system at work. Sound waves from the outside world travel into your ear canal, causing your eardrum to vibrate.
Okay.
These vibrations are then passed along by three tiny bones, the ossicles, to a spiral-shaped part in your inner ear called the cochlea. Think of it as your inner ear's intricate sound analyzer.
Like a little snail shell.
Kind of, yeah. Inside the cochlea is fluid, and the vibrations cause this fluid to move, activating thousands of tiny hair-like cells. These cells then send messages through the auditory nerve.
To the hearing center of the brain. And where does that information end up?
It goes to the auditory cortex, which, like the smell processing area, is also located in the temporal lobe near your ears.
Ah, the temporal lobe again. So memory and perception are nearby.
Exactly. And what's fascinating is how different aspects of sound, the tempo of music, the words being spoken, the loudness can directly impact your emotions, your mental activity, and even your physical reactions.
The research we looked at mentions a study where brain activity was monitored while people listened to music around 60 beats per minute. What happened there?
Yeah, that was a Stanford study. They found that brain waves associated with relaxation, the alpha waves, actually synced up with the music's rhythm.
Wow.
It suggests a direct link between the rhythm of sound and our brain activity. And it goes further slow. Rhythms can even help induce brain waves linked to sleep, like theta waves.
That's incredible. And it's not just a one-way street, is it? The information suggests that the auditory nerve can also work in reverse.
That's right. It allows your brain to essentially tell your ear to kind of tune out background noise and focus on important sounds.
Ah, the cocktail party effect.
Exactly. Or it explains why someone engrossed in looking at art or reading might not even hear you calling their name.
Right, their brain is actively filtering.
Precisely. They're filtering out less relevant sound information to focus on what they're engaged in. And it's not just about consciously recognizing sounds. Your brain also reacts chemically to the fundamental properties of sound, the frequency, the vibration, the tone. And these reactions can significantly alter your mood and perception, often beneath your conscious awareness.
Okay, let's switch to sight now. Once you open your eyes, you're immediately taking in light, color, everything in your visual field. How does this whole process work?
Well, seeing is all about processing light. Your eyes work a lot like a camera, in a simplified sense.
Okay, camera analogy, I get that.
They take in light, and that light is converted into electrical signals by specialized cells in the retina called photoreceptors, rods, and cones.
Right.
These signals are then sent along the optic nerve, like a cable, to the back of your brain, to the occipital lobe, which is the visual processing center.
And that's where your brain turns those electrical signals into the images you actually see.
Exactly. The occipital lobe is where we perceive shapes, colors, movement, recognize faces, and appreciate the objects around us. And neuroscientists are finding that a specific area within this region, the lateral occipital area, plays a key role in how we process and develop an aesthetic appreciation for art.
Interesting. So there's a specific spot for art appreciation.
It seems to be heavily involved, yeah.
All right, last but not least, let's talk about touch. Sometimes we might not think about it much, but the information highlights just how incredibly sensitive our skin and nerve endings are.
It's truly remarkable. I mean, think about it. The sources mention hundreds of thousands of nerve endings in each of your feet alone.
That's wild. So how does that signal travel?
Touch detectors in your skin connect to nerve cells, neurons in your spinal cord. These signals then travel up to a relay station deep in the middle of your brain called the thalamus.
The thalamus, okay.
And from there, they're sent to the touch processing area of your brain, the somatosensory cortex.
The somatosensory cortex, where is that located?
It's in the parietal lobe, sort of in the upper middle part of your brain, just behind the frontal lobe.
Got it. Parietal lobe for touch.
Right. This area is absolutely critical for processing all things touch. And what's fascinating is that different neurons within this cortex react in unique ways to the different aspects of touch: texture, pressure, temperature, vibration, pain, and so on.
You know, our rich vocabulary for describing texture, smooth, rough, silky, bumpy, it really shows how nuanced our sense of touch is.
It absolutely does. And touch is also a powerful way we communicate. It's actually one of the first senses to evolve.
It's a powerful way we connect with each other, isn't it? Like nonverbal communication.
Absolutely. Think about how we share feelings through something as simple as holding a hand or giving a hug. And it turns out touch has a rapid effect on our brain chemistry and mental state.
Also,
Well, it triggers the release of oxytocin, that love hormone we mentioned with smell.
Oxytocin again.
Yeah, it contributes to feelings of trust, generosity, compassion, and even lowers anxiety. Research even suggests we can interpret the intention behind someone's touch, like sympathy versus anger, just through our sense receptors.
Wow. And there's a memory connection, too.
A strong one. Recent research indicates a really compelling link between touch and long-lasting memories. It can even engage visual processing regions when you can't see what you're touching, like in that study where people identified objects like spoons just by touch.
Wow, that really underscores the power of touch.
Yeah.
So when we consider all of this together, smell, taste, hearing, sight, touch, our bodies are constantly receiving sensory information.
All the time.
And these biological reactions happen incredibly fast.
Yeah.
And much of this happens without us even being consciously aware of it, right?
Yeah.
Something like 95%.
Precisely. The vast majority of sensory processing happens outside our conscious radar. Our attentional processes play a huge role in what we actually notice.
So you walk into a room.
Exactly. You walk into a room, you're probably not consciously registering every detail, the specific shade of paint, the hum of the lights, the texture of the chair,
Right.
even though your body is reacting to it, all the light, the color, the temperature, maybe a faint smell, the feel of the air. You and your environment are basically inseparable.
And our senses lay the groundwork for how arts and aesthetics impact our well-being.
Absolutely. They're the foundation.